This SKF bearing being analyzed while in service by a technician with a wireless scanner. It's an example of how the new connectivity is changing products and the approach to product lifecycle management. Now, bearings are a good example of a widely used and relatively undifferentiated and conceptually simple mechanical product deployed in almost every industry that uses mechanical devices. Anti-friction bearings they're specified during the design process to handle continuous and shock loads under local conditions for either maximum runtime between scheduled replacement or specified mean time between failures. Now, depending on the market, the necessary mean time between failures might be measured in years. Now, in reliability engineering, the bathtub curve, well, it's one way to visualize that mean time between failures problem. The blue line represents the observed failure rate, the aggregate of failures and infant mortality, and the natural failure due to end of life, and the probability of random failures in between. That's the other curves in the graph. Now, the low point in that graph, the blue line, represents the time in the service life of the product with the lowest probability of a service failure. But statistics like these are generated by measuring the incidence of failures over time. So this is post-mortem analysis made after in-service failures, and it's not predictive. Could that blue curve be extrapolated from information aggregated by the bearing before it causes a costly failure?
Product designs for each domain can be easily searched and securely shared, which improves design reuse, quality, and reliability. And with visibility to cross-domain dependencies, engineers can see the impact of their designs and make better product decisions. The power of this connected information is behind everything you see. Product designs for each domain can be easily searched and securely shared, which improves design reuse, quality, and reliability. With visibility to requirements and cross-domain dependencies, engineers can see the impact of their designs and make better product decisions. If you're looking at a component, you don't have to go off and search for the latest drawing or geometry. It's there. If you're viewing a document, you don't have to wonder if it's been approved. You can clearly see its status and history. If you need to see the requirements driving a software change, it's there. You don't waste time searching for information. With our Teamcenter software, whatever mechanical, electrical, electronic, and software design tools you use, PLM can be accessed inside the design environment, so you can be comfortable using PLM in the system in which you're already accustomed to using. It's full access to PLM, not just for things like check-in and check-out. It's searching for data, reusing data, data security, check-in and out, viewing requirements, viewing and completing your project and program task and deliverables, viewing related documents, initiating workflows, participating in change, and much, much more. Let's look at a customer developing smart connected products. Polar Electro, which makes some of the world's leading smart fitness trackers, uses Teamcenter for cross-domain design management. By bringing together mechanical, electronic, and software tools and processes, companies like Polar improve collaboration across business functions to speed up development cycles and meet program and project targets. Looking at their quote, we've integrated NX and Mentor tools with Teamcenter. We also manage our hardware and software compatibility in Teamcenter. Let's break it down into a discussion of each fundamental discipline. Let's start with mechanical design management. PLM software supports integrations with mechanical CAD design tools to find what you're looking for faster and maximize reuse. You can establish the relationships and dependencies to requirements and data in other domains, as well as the various product configurations. Since there may be many tools used across your global design chain, Teamcenter's support for multiple CAD tools and multi-CAD design processes helps you avoid data translations and helps you maximize the reuse of proven designs. And the 3D models, along with the product manufacturing information, or PMI, helps to smooth the transition to manufacturing. Teamcenter is hosted within the native mechanical CAD environment, providing access to a full range of PLM functionality. This lets you get to the data you need quickly. It lets you securely access designs, manage data revisions, initiate structured workflow and change processes, and more. Also, Teamcenter converts multi-CAD data into the CAD-neutral JT format automatically, so you can reuse, create, shape, and modify component designs in your preferred MCAD system and incorporate them into multi-CAD assemblies and product designs. We'll now focus on electrical design management. Integration of electrical data into the overall product structure is required to get a full picture of the platform. Requirements integration to the electrical system drives traceability between the various levels of electrical abstraction. One key output from the electrical design process is a fully defined harness down to the specific part numbers for every component, including things like terminals and plugs that must be fit into or onto the wire ends and inserted into connector cavities. This full harness content BOM can be published to Teamcenter, where it can be consumed into higher level BOMs or used to feed the ordering and manufacturing process. Teamcenter offers integration with electrical design tools, AutoCAD Electrical, and our own Siemens products, VSys and Capital. As shown here, Capital uses embedded Teamcenter in all electrical design applications to provide users direct and integrated access to PLM managed data and structure. This provides a familiar and consistent environment for designers who must interact with and drive their electrical design process from the master Teamcenter process. Now let's look at how you bring electrical designs into your collaborative product development environment to interrogate tools, data, and processes. Teamcenter provides a single source for all your ECAD data and process knowledge that help design teams to find what's needed faster and maximize reuse and increase productivity. While Expedition and PADS are our own PCB design products, Teamcenter supports integrations for all major ECAD tools. For complex and multi-board design, ECAD integration with Teamcenter enables a fully parallel collaborative design environment where global teams can work concurrently to develop innovation and competitive products. Designers can save the released version of their designs to Teamcenter, providing access to all the other stakeholders. Automatic synchronization with local tool libraries ensures everyone has access to accurate and consistent part information. The ECAD and MCAD Common Part Library enables collaborative design by allowing both the ECAD and MCAD designers to share a common parts library definition. Now let's take a look at how you integrate software with the rest of the product development. By treating your software as the valuable parts of the product they are, you can establish the relationships and dependencies between software and hardware objects needed to increase product quality and reliability. Application Lifecycle Management integration to Teamcenter, or ALM to PLM integration, enables true interoperability to get software development out of its silo and integrated with the rest of your product development processes. Bidirectional linking of ALM and PLM design data delivers multidisciplinary development. It provides you with the ability to quickly access the cross-domain impact of product changes and end-to-end traceability for complex multi-system product development. Software design is essential to many products, and that's why Teamcenter is integrated with our own Polarian application lifecycle management product to manage the whole software lifecycle. In Teamcenter, cross-domain development teams can manage the software binaries and incorporate them into the product bill of materials, as well as link any other associated software artifacts with the electronic control units, the ECUs, and it also manages all the hardware and software dependencies. For more information about the value of PLM and Teamcenter options to get into production quickly, I invite you to visit us on the web. Take our free 30-day PLM software test drive.